You know, when you walk through your city, you see the obvious stuff, right? The buildings, the traffic lights, the buses. But what if I told you that just beneath the surface, there's a hidden intelligence, a kind of digital brain that's starting to connect everything? That's what we're going to dive into. The unseen AI that is literally transforming our cities from the inside out.
So here's the plan. We're going to start by uncovering this invisible brain of the city. Then we'll look at how it's totally changing the game for our power grids and our water systems. After that, we'll hit the streets to see how AI is tackling traffic and even get a glimpse of how it's helping design future cities. And finally, we'll get into the really big question, the dilemma at the heart of all this incredible progress. All right, so first things first. I want you to try seeing your city a little differently. Not just as, a bunch of concrete and steel, but more like a living thing, a giant, complex organism. And if the city is an organism, then AI, well, that's becoming its central nervous system. This hidden network, processing just insane amounts of information to make everything tick.
So what if this city's brain could predict a power outage before it happens? Or what if it could spot a water main leak and get it fixed before the street floods? This stuff, it's not science fiction anymore. This is the whole idea, the very core of what we call a smart city.
Okay, so what is a smart city, really? At its heart, it's pretty straightforward. It's an urban area that's just packed with sensors. These sensors collect data on, well, everything. Traffic flow, energy use, air quality, you name it. Then, and this is the key part, AI crunches all that data to find patterns and insights. The goal? To make everything run smoother, faster, and just better. It really is all about efficiency. So let's see this city brain in action. A perfect place to start is something we all take for granted until it's gone, the electrical grid. I mean, for more than 100 years, our power grid has been a pretty dumb one-way street. Power flows from the plant to you, and that's it. But AI? AI is coming in and completely rewriting the rule book. And you can really see the difference here. The traditional grid, it's all reactive. It just pushes power out from one big plant, and when something breaks, someone gets a call and they go fix it. But a smart grid, that's a whole different beast. It's a dynamic, two-way conversation. It can actually anticipate problems before they happen, automatically reroute power around a fault, and this is huge, it can handle all those new distributed energy sources, like solar panels on your roof or wind farms.
So how does AI actually do all this? Well, for starters, it's amazing at forecasting. AI models can look at weather data and predict a huge spike in energy demand during a heat wave, helping utilities prepare and prevent blackouts. It also helps balance the load on the grid, maybe by telling your smart devices to run when power is cheaper. It can even predict when a specific piece of equipment, like a transformer, is about to fail. And get this is wild. It uses a really cool type of AI called reinforcement learning. Basically, the AI practices in a simulation, learning by trial and error how to spot and fight off cyber attacks on the grid. It's like having a digital security guard that never sleeps.
Now, this same incredible predictive power isn't just for electricity. It's also being used for another vital resource that's flowing right under our feet, and, unfortunately, often leaking out: our water.
And the scale of the problem here is just staggering. Think about this. Globally, somewhere between 20 and 30%, up to a third, of all our clean, treated drinking water never even makes it to your faucet. It's just gone, leaking out of aging pipe networks, some of which are literally 100 years old.
So how does AI help? Well, instead of waiting for a massive pipe to burst, cities are putting sensors on their water mains. These sensors are constantly collecting data, pressure, flow rate, you name it. Then, powerful deep learning algorithms get to work. They combine the sensor readings with info about the pipe itself, like its age and what it's made of, and they can spot the subtle warning signs that a break is about to happen. This means a crew can be sent to fix a weak spot before it turns into a geyser shooting up through the middle of the street.
Okay, so we've got power and water covered. Now let's come up from underground and talk about something that drives pretty much everyone crazy in a city: traffic.
Think about your commute for a second. How many times have you sat at a red light with literally no one coming the other way? It's maddening. Well, with AI, those dumb timers are being replaced by adaptive signals that watch the actual traffic flow. It's also being used to make public transit way better, planning bus routes based on where people actually need to go today. And maybe most importantly, when there's an emergency, AI systems can find the absolute fastest route for an ambulance, shaving off precious minutes that can literally be the difference between life and death. But it gets even more detailed than that, and this is where it gets really cool. AI-powered computer vision can watch an intersection and identify not just the accidents that happen, but the near misses. You know, those heart-stopping moments where a car just barely avoids hitting a pedestrian. That data is pure gold for city planners. It shows them exactly which intersections are the most dangerous and why, so they can go in and redesign them to prevent the tragedy before it ever happens.
Okay, so everything we've talked about so far is about using AI to manage the cities we've already got. But what if we could use AI to help us design the cities of the future from the ground up? This is where this amazing concept called generative design comes into play. Think of it like a creative partnership. An architect can go to the AI with a set of goals. Like, okay, I need to design a new neighborhood, I want to maximize natural sunlight, minimize wind tunnels, and make sure everyone is close to a park. The AI then becomes this incredible brainstorming partner, generating literally thousands of different design options that meet all those criteria for the human designer to review and refine.
And planners can take this idea even further with something called a digital twin. It's exactly what it sounds like, a super detailed virtual replica of an entire city. It's like SimCity, but for the real world on steroids. With a digital twin, you can test out huge infrastructure projects before you even break ground. What happens if we build a new subway line here? How will this new skyscraper affect traffic? You can simulate all of it and fix problems in the virtual world before spending millions of dollars on a mistake in the real one.
All right, all of this sounds pretty amazing, right? All this efficiency, this predictive power, this optimization. It's easy to get excited. But, and this is a big but, we have to talk about the other side of the coin. Every single conversation about smart cities has to tackle the risks and the potential dangers. Because here's the fundamental dilemma, the double-edged sword. That promise of efficiency, it comes with the peril of mass surveillance and a loss of privacy. The promise of enhanced safety, it creates massive cybersecurity vulnerabilities. A whole city connected to one grid is a very tempting target. And the promise of responsive public services, well, that runs the risk of algorithmic bias. If the data we feed the AI is biased, its decisions will be too, potentially making life worse for already marginalized communities. And that really gets to the heart of it. The technology, the AI, it's just a tool. It's not inherently good or bad. The real challenge isn't a technical one, it's a human one. It's about how we choose to use these powerful tools. It's about making sure that as our cities get smarter, they also get wiser and more just. So this all leaves us with probably the most important question we have to face. The end goal can't just be efficiency for efficiency's sake. As we continue to weave this incredible intelligence into the very fabric of our urban lives, we have to keep asking ourselves over and over again, as our cities get smarter, how do we make sure they stay human?